Welcome! In this lesson, we will be discussing atomic structure, and in particular, subatomic particles. But first, we need to talk about elements. So an element is a pure substance that cannot be separated into simpler substances by a chemical change. Every element is made up of individual atoms that have exactly the same number of protons in their nucleus, and we'll talk more about the specifics of that in just a minute. All of our elements are arranged on the periodic table, which will become a huge resource for us this year. So examples of elements are carbon. This is a diamond, and every atom in this diamond is a carbon atom, and there are no other types of atoms in this pure substance. We also have neon. You may have seen these in lights around town. Every atom in these tubes is made of neon. And we also have sulfur, which is this sort of yellow solid. And every single atom in this sulfur chunk is exactly the same. An atom is the basic unit of all matter. Every single type of matter is made up of atoms, and each atom is made up of subatomic particles, and there's 3 in particular. We've got protons, neutrons, and electrons. And we'll talk about each of these individually, but we can find information about them on Table O in our reference tables. Let's start with protons. Protons are going to be located inside the nucleus, or the center of an atom. Protons, as particles, have a positive charge on them of +1. And they have a mass that's equal to that of a neutron. And that is going to be known as 1 atomic mass unit. And this is a special kind of unit that's just for atoms. In our reference tables, the atomic mass unit is abbreviated as a small u. Other places might call an atomic mass unit an AMU. But we'll follow the reference tables for now. And we defined that atomic mass unit as 1/12 the mass of a carbon-12 atom. We'll talk more about how we designate carbon atoms in a little bit. And the important thing about protons is that each element has a characteristic number of protons. So, for example, a carbon atom has 6 protons, always. If we change that to 7 protons, now all of a sudden we're going to have a different type of element, which would be nitrogen. So protons are really important in defining the type of element that we have. And there are a couple of ways that we can designate or write a symbol for a proton. So we can have a P, or we can have an H. Both of these signify protons. The other subatomic particle in the nucleus is our neutron. And neutrons are neutral particles. So neutral equals no charge, or charge equals 0. This is different than our proton, which has a positive charge. Again, this is found inside the nucleus of the atom, and it has a mass equal to that of the proton, or 1 atomic mass unit, or 1 U. And we can see in this example of the carbon atom, we have 6 neutrons inside of our nucleus. And we can also indicate a neutron with the symbol of a lowercase n. Our third subatomic particle is going to be an electron. And electrons are going to be located outside of the nucleus, so they're very far away from our protons and our neutrons that are in the nucleus. Electrons have a negative charge of -1, and their mass is quite small. It's equal to 1/1836 the mass of a proton, which is so small that we often just don't count it when we're considering the total mass of the atom. It's there, but it's really hard to calculate. We can indicate electrons with some symbols. So this is a beta, which is a Greek letter, or an E. And our electrons, we often think of them in rings around the center of our atom, but our most current model of the atom describes the electrons as being found in regions called orbitals, as we can see down here. So our electrons are moving around in an electron cloud or in an orbital. And the nucleus of the atom, we've talked about this a lot already, but it's a small concentrated core of the atom. The only subatomic particles that are in the nucleus are protons and neutrons. And this is where most of the mass of the atom is. I like to remember that protons and neutrons are in the nucleus. Protons and neutrons. N and P are close together in the alphabet, and they're also close together in the nucleus. Overall, the charge of the nucleus is positive, right? The only charged particles in the nucleus are our protons, which have a positive charge. So our nuclear charge equals the number of protons that are in our atom. Right? And then that nucleus is again going to be surrounded by our negatively charged electrons. So this is a Bohr model of our atom. We've got our nucleus in the center. It has protons and neutrons. And then in orbitals around the nucleus, we have our electrons. So in summary, we talked about elements and atoms. We defined all of the subatomic particles, and we learned which particles are in the nucleus. So you should be able to identify all of these particles and their location in an atom. Okay, good job today. See you next time.